Okay, so here's the where we left off last time we met. It's a widget list editor that we're going to be using as the student side of a content management system for managing courses. I'm sorry, this is still the faculty side, right? The faculty creating content, being able to add widgets to a particular topic, widgets including videos and perhaps slides and headings and lists and, or raw HTML content to a page. We looked at a couple of generic widgets plus a couple of specific widgets such as a heading widget, a list widget, and also a YouTube widget. I removed the YouTube widget since it's not required for this assignment. It was there at some point and then I removed it. Maybe I should put it back. No, I'll leave it. All right, so we played around with this, and we saw that we can generate a on-the-fly preview, and we had said that one of the requirements was to provide a global preview button, right? That would hide everything and only show the preview. So I think that's pretty easy. Let's look at how to be able to save this. Our work to the server, and then perhaps when we come back tomorrow, we load the application. We should be able to go and fetch this data from the server, right, and reconstruct the user interface based on what you saved the previous day. Okay, so we did test the capability of being able to save. Let's see. Okay, that's not working. Maybe we don't have the server up and running. Let me see. Okay, so it was this was a server that we worked on yesterday. We created a widget repository. We created a widget model. The model just had a title and an ID, and plus it had a widget service that allowed us to post the entire list of widgets as part of the body. And then we checked that this was working. Let's try and see if we can get where we were yesterday. Let's see. So this is going to start the server, and it's going to expose this particular endpoint where we can post to save the list of widgets. So let's try it again. Let's clear that and save again. All right, so that this time worked, and it echoed back exactly what we sent it. Actually, not everything, because we only in the data model on the server we're only capturing the title and the ID, right? We're not capturing anything else. Obviously, for the list widget, we would need to capture the list item. For the headings, we would need to capture the size, the text, and here we're choosing to use a modeling technique where instead of creating multiple classes where each inherits several base class several derived classes inherit from a base class. We're choosing to use a technique that will store this in the database in what is called a denormalized strategy. Right? What we'll do is that in Java, what we typically would do is that you would have a base class widget, and then underneath you would have several base classes that would inherit. Several derived classes that would inherit from widget. So like the heading widget, the YouTube widget, the list widget would all inherit from widget. Right? And they would all add additional properties such as the list items, right? The size, the text, and so that would provide us with a challenge on how would we map inheritance. It's something that's a very common concept in object-oriented technology and object-oriented languages, but it's not natively supported by relational databases. Okay, so there's several strategies to map this gap between the relational from the relational world and the object world. The easiest and typically the common way of doing it is to denormalize the data model. Right, instead of splitting it up into multiple classes, multiple tables, right, is bring all the feature, all the attributes, properties of all the derived classes onto one single class, right? That would map directly to one table, right? There are other strategies where you would keep the inheritance, and then you would ask and you would implement in the relational data model one class, one table per class. Okay, we're not going to look at that just yet. Right? When we a little later, we'll toy around with some of those strategies. That's a topic we cover quite a bit in 5200 in databases. But let's leave that for a later discussion. Okay. Right now, let's use the denormalized approach. Right. Everything modeled in a single table in a single class. Okay. All right. All right. So yeah. So we have the title. We have the ID. Other things that might be here would be the list items, right? That's for the list, right? And also whether it's ordered or unordered, right? So that's ordered. What else? So that's for the list. So this is for the list widget, right? So this is for the list widget. What else? We need maybe for the heading widget. What do we have there? We have I think it was the text and maybe the size, right? So private int size. What else? If we had a YouTube widget, maybe the video ID would live here as well. Okay, right? So let's create also the setters and getters for this, and we'll add them towards the bottom. Select all. Okay, there we have. We have all the setters and getters for each one of these. Since we have that, since we changed the data model, let's restart the server, and let's see if we can store all this data. Save, yes. Notice that the names that we use here for these attributes are identical to the property names that we use in JSON. Okay, and by default, what Java will do, this web service, what it will do is that it will parse the JSON object and it will do a one-to-one mapping of the JSON attribute names with the Java attribute names. Right? If they match, then the mapping will be one-to-one. Okay? Right. So yes, I was careful to name these attributes the same exact name that I'm using on the React side, right? So that the JSONs match. Let me check to see that what we sent over. We did send over. So for instance, here's the list widget. Did I spell this right? Let's see. Ordered. Widget type. Do we have widget type? Oh, we didn't have widget type. We should have that as well. Title, list items I did add. Ordered, false. Widget type, we should add that too. Let's go back and let's add this. Let's add this as a private string widget type. What else do we need? We could, for instance, later on, we'll play around with the order. We're being able to move it up and down and whatnot. So we'll add that in a minute. Let's leave that for now. Let's see for the heading widget. What do we need? We need the. Apparently, we don't have a size. So let's choose a size. So let's clear that. Let's choose a size and the text. And let's save. Let's see the heading widget. Okay, so size. It looks like it's sending a string representation, right? We should change that to an integer. The text is text. That's fine. Okay. Perhaps on the React side, we should make sure that when we generate the size, right, that it's an integer, right? So that it maps correctly to the same data type on the Java side, right? And that happens where? That happens, I believe, that happens on the heading widget. Here in the heading widget, when we do an update, right, and select the size, what do? We do widget.size, and we're going to parse it, right, to make sure that it's an integer, right? That we send it the correct data type. So we can say parse int. Okay, so let's try that out again. Let's make sure that we're sending the correct data type. So let's clear this out. Let's save. Let's see what we're sending. So the heading widget. Okay, size is now a number. That's perfect, right? So that is the correct data type. All right, so we have that. What about on the server side? We added the widget type. Size is an integer. That's correct. I think we can restart the server since we added widget type. Okay. Oh, we don't have a setter and getter for this. Let's make sure we have that too. Let's stop the server. Let's do source, and let's generate a setter and getter for our new widget type. And let's add it at the bottom. Okay, I think we have both sides on the client side and the server side matching. Let's start the server. Let's make sure that at least see that it echoes back exactly what we sent it, right? Minus maybe the order, which we didn't add the order just yet. All right, we'll add the order in a minute. Okay, we have the server running. Let's save it again. Let's clear this. Let's save it. Okay, it went. Not sure that it. Okay, it responded. This is the response. Let's see that it responded correctly. Very good. The size is correct. The title is there. The widget type. So it is getting to the server and it's echoing back exactly what we sent it. Perfect. All right. So let's make sure now that we can save it to the database. Let's see. So it should have in the database with our new widget data model. It should have created for us the correct schema. Let's look at the columns that were generated. Notice that we have the widget type is there. See that? Notice the naming convention. Right? It knows that that the right naming convention is being used on Java. The naming convention is that it's camel cased. Yes. Every word is capitalized, but in SQL, it's case insensitive, right? So it makes sure that it uses a naming convention that, for instance, it replaces all the capital letters with underscore and then the lowercase, right? Same thing with list item, right? Item was capitalized, so it replaced it with underscore item. So okay, so the mapping worked fine. We have the ID, the title, the size, the text. I think we have everything we need to save it. Although we don't have any data there, we can query, and we don't have any actual data, right? So let's save it. So how do we do that? Also, I call on the server. What we could do in the service, in the widget service. Right now, we're just echoing it back. Right? That's all we're doing. But what we could do is that instead of just echoing it, we could iterate over each one of these. And just save them and do inserts for each one of these, right? So let's do that. We can say for widget in widgets. You know, as we iterate over these, we can just use the repository that we created earlier, right? So we did create it earlier, didn't we? Here it is, the widget repository, right? So let's use it here in the service. What we could do is inject it. We can auto wire it. So auto wired it in here. So this will be widget repository. Oops. Repository. So widget repository. Okay, let's auto wire that. And now we could use the repository to save each one of these widgets at a time. We can say widget repository .save and the widget. And this will do inserts into a database. Okay? We don't really need to return anything. We could perhaps create another widget list here, widget saved widgets. So this would be maybe a new array list of widgets. And as they're being saved, we can append it into our saved widgets list. All right, so we can say, as they're being saved, we can say widget save widgets.add add the widget that is saved. Notice because the IDs that we're providing, right, those are IDs that we're generating on the client, right? They really have no meaning on the server side, right? These are IDs that are going to be generated really by the server, right, by the database when we insert it, right? Because I believe we declared it as auto increment. Yeah, we said that these were auto-generated, right, generated by the database, right? So we're going to ignore that integer. All right, excellent. So let's go back here. Let's go to save it, and then we can return here. We can return the saved widgets, right? That's going to have the actual IDs of the real objects that were actually inserted in the database. Everybody good? All right. Okay, excellent. So let's try it out. Let's restart the server, and let's see if we can insert all these in there. All right, excellent. Let's try and save now. Let's do a save. Notice that what came back, heading widget. Wait a minute. What? Let's see what was inserted. Let's do a query. There we have it. We have the widgets haven't been added there. We have a heading, WT1, WT2, WT3. So the ones that we had on the server, right? These are the same exact widgets that we sent over, right? And they finally were inserted in the database. What we'd like to be able to do is that if we make any changes, for instance, we might want to change the title, or we might want to change the type, right? We'd like to be able to send that as well, right? So, for instance, say we make a change here, and we change the title or something, or the type. For instance, say of WT1, widget 1. So where's widget 1? Where's widget 1? Right here. And we change it, WT1 to maybe WT3. We don't have anything else, right? So let's save it again. Or let's change it all to WT2. Let's see what happens. WT2, WT2, and WT2. All right, and let's save that. Let's see what comes back. Notice that they were all changed with WT2. Apparently, there was one that I missed, WT3 over here. Let's see what the database says, and let's refresh. Okay, notice what's happening here, right? Something weird is happening. They're being reinserted, right? Saying, well, you already had some widgets in there, and you're sending me a brand new. It can't distinguish the fact that you had already some widgets in there, and these are actually the same widgets, right? So there are two strategies to deal with this. One easy, one hard. The easy is to just reinsert them all over again, right? It just forget what I had earlier. Just reinsert them all again. Just throw away what I had earlier and just throw it away, and then restart. And this is okay if the content is small, right? Maybe I have 10, 20, 30 widgets, and maybe that's not too unreasonable. From a faculty's point of view, perhaps I'm not going to have more than 100 widgets perhaps per topic. So that might be something reasonable, right? And also, this is not something that I'm going to be doing every single day, right? I make the changes. Once I make the change, typically these change very slowly, right? It's not going to be a heavy traffic. Lots and lots of insert, lots and lots of updates. So perhaps that might be a reasonable assumption. The other would be to do an upsert, meaning check to see if it's already there. If it is, do a comparison. If anything has changed, then do change only that one record. Okay. So iterate over all of them and see which one changes, and then change that one. The other one is to do a every time I change, right? Every time I change, identify when you stopped changing, and then send an update only on that one widget. Okay, that would be the best thing, right? To do an update of that one single record. Okay, right? And if this were a database class, I would certainly ask you for the later one. Here we're going to go the easy way. All right, we're just going to say, just remove all of them and reinsert everything in there. Okay, so let's do that. What we can do on the server, notice all the inserts. See that? You can see the inserts that JPA is sending to a database. See, that's really cool. Seeing exactly how what the SQL is being used to talk to a database. Anyway, so let's do that. What we're going to do is that we're going to remove all the records that were already there. So we could do that with repository. The widget repository will provide us that. We can say widget repository dot, and there's a delete all. See that? That's like a truncate. Truncate the table, right? It removes all the records, and they're all gone. And then we're just going to reinsert them back in. Okay? All right. So let's try that. Let's restart. Let's see. Okay, notice that every time I save, right? Notice that it's going out to the server and it comes back. It's the same exact data, right? The only thing that is changing from one query to the next is the IDs. See the IDs? They're changing, right? Because they're auto-incremented, and you just remove the previous ones, right? And then it just regenerates the next 6 IDs that it needs to make these unique. Right? So it's exactly the same data that we had originally. We have the list widgets, the WT2s are there. If I make any change, let's see the list widget. We even have the list items there, item 1, 2, and 3. If we change this and add a couple more items, let's see, make sure that that's being saved. So item 4, item 5, and let's clear this and let's save again. Let's see what's coming back, and notice that the list widget, indeed, it has all the items in there, right? So it is being saved to the server, right? Yes.
When you hit save, this case it calls delete all. So let's say you were working on, like you had 2 lessons that you had widgets in, and you only wanted to save like one, like topic with its lesson. So would it delete everything from the other lesson too?
Yes. In this case, it would. Yes.
So then you would have to.
So you would have a more targeted delete, right? Maybe delete only the ones for this particular lesson. Yeah. And there is a delete per particular ID. Yes.
What about your environment or your database schema increments, auto increments by 1, whereas mine, or I don't know if any other students, mine increments by 10, starting with.
Yeah, that's fine.
It doesn't matter.
Yeah, no, it doesn't matter. Yeah, the IDs are. I'm sorry. Yeah, you can set what the default is, and the default for ClearDB or for other databases is 10. But you can that's if you want to. They give you like a 10 in between, so if you want to insert 11, 12, 13, things like that. But the actual value of the ID should be irrelevant to you, right? You should never care what those IDs are. The actual value of those IDs are. They only matter to you logically. All right, so we know we have saved data into the database, right? We would like to be able to go the other way around, right? Make sure that when we come back tomorrow, that information has been saved. Notice that right now, this list of items, if I refresh the page, everything's gone. I don't have those items that I had earlier, even though I know they're in the database, right? So let's focus now on how is it that we can update our state, not from the hard-coded state that we currently have, but from the database. All right, so let's take a look at that now.